So one of my student has asked me a doubt based on Brewster's angle. Let's just discuss what a Brewster's angle is and then we'll come to the numerical. Now, you can see that we have some medium, a glass medium, and on the other side we have a rarer medium which is air, and this one is the denser medium. Now when an unpolarized light is coming from here and getting incident on this medium, some part of it gets refracted, which we call the refracted light, and some part of it gets reflected. Now the good part is that the reflected light is basically polarized. So it is not always that whenever you put any light on it and incident it on the surface it will always come out polarized. It's not like that. There has to be some particular angle on which you have to incident the light, and the result will be that the reflected light will come out to be polarized. There has to be some angle in which you have to incident that light, and that particular angle, that incident angle, is nothing but the Brewster's angle. If you look at the definition, the angle of incidence at which a beam of unpolarized light falling on a transparent surface is reflected as a beam of completely plain polarized light is called polarizing or the Brewster's angle. Okay, and the second part that you have to remember is that this reflected light and the refracted light, they both are perpendicular to each other. So there are just two things that you need to remember. First is you have to fix some angle of incidence at which the reflection will be polarized. Only that angle is called the Brewster's angle. Secondly, these both, the reflected and the refracted, are basically perpendicular to each other. And if I come to the formula of that, you can see the formula is mu equals tan IP. So IP is basically the Brewster's angle, the incident angle, and mu is basically the refractive index of second medium with respect to first. And why I have written it, like I can also write it mu2 upon mu1. The reason I have not written it, because the first medium is the air only. Look, the first medium is air and the second medium is glass, and we know that the refractive index for air is taken to be 1. That's why we have just written down mu instead of mu2 upon mu1. Now let's move to the numerical. The numerical says a person lives in a high-rise building on the bank of a river 50-meter wide. So this is the river and the river is 50 meters wide. Across the river is a well-lit tower of height 40 meters. So this one. When the person who is at a height of 10 meters, the person is right up here and the distance of the person from the ground is 10 meters. The person looks through a polarizer at an appropriate angle at light of the tower reflecting from the river surface. He notes that the intensity of the light coming from the distance x from his building is the least, and this corresponds to the light coming from the light bulb at a height of y on the tower. Now this whole complete line is a big mess. I'll just tell you straight that basically I'm just making a line like that. Okay, so this distance was x. The x is basically the distance which is away from his the position of the person, and basically this much distance away he basically finds a particular point from which the light is incident and getting reflected. Now this is where the Brewster's angle is getting applied. So this time we have some incident ray falling on a different medium. Now here it is basically a river, right? So the medium is water and the light rays coming from air. So the unpolarized light is coming from air touching the medium water, and definitely it is, there has to be some incident angle. So the angle at which it is getting hit to the surface of water reflects it in such a way that it becomes polarized. So this is where the Brewster's angle comes in place. This particular point is x distance away from his own position and this particular height is y. Now what do we have to find out is the values of x and y. Okay, first of all, the key thing is we need to find out this incident Brewster's angle. And how will we do that? Using the Brewster's law. The formula was, as I showed you, mu equals tan IP. So basically mu is nothing but the mu2 upon mu1. So mu2 here is water and this is air. So air we know already has value 1, so we can directly put the value of water, and the value for water is given to be 4 by 3. So 4 by 3 equals 10 IP. And if you want to find IP, you will take tan inverse of 4 by 3, and you can use a calculator for that, and the value that you will get will be 53 degrees. It means this angle is 53 degrees, and obviously if it is getting reflected, so this angle is also 53. And how much will be this much angle? You can easily calculate that, because this whole thing is 90, so the rest of the angle is 37 degree, and the same for this side as well. Now this is 37. So you have got two triangles with angles 37 and 37. Now it's very easy. If this whole thing is 50, and out of that this much is x, so this much will be 50 minus x, right? You want to find out y, and you want to find out x. Using the first triangle, I will just simply use trigonometry. The angle is 37, this distance is x, and this one is 10. So why not to use tan? So tan 37 degrees is basically equal to 10 divided by x. So you can easily calculate the x from here. And if you go for y, so you use the second triangle. In this triangle as well, we have this height, which is y, and this is 50 minus x, and obviously you will figure out the x from here. So tan again 37 degrees is equal to y divided by 50 minus x. So whatever the value you get from here, put it here, and you will get the value for y as well. That's it.